I'm Gerard van der Geer. I'm from the Netherlands. I'm from the University of Amsterdam. Well, actually, I studied mathematics in Leiden University, and I did my PhD there under Van der Ven. Van der Ven was an expert in complex surfaces, and so he proposed that I work on Hilbert modular surfaces, and so I did, and I wrote my thesis about that. And that, of course, brought me in a very natural way into contact with Hirzebruch and Geer and Bonn. And so I spent here in Bonn 1.5 years as a postdoc after my PhD. And then I returned to the Netherlands, but I went to Amsterdam, where I got a tenure track position. And then a couple of years later, I spent a year in the United States, and then I returned as a professor to the University of Amsterdam, and there I have been since till I retired, which is in 2017. But I'm still active, and so I'm here, for example. But I also visit every year 2 months in the autumn in Beijing at the Yao Institute of Tsinghua University, and so it's for me a great pleasure to be still active. Yeah, my mathematical interest is what I really like is the area where geometry and number theory mix. And so the Hilbert modular surfaces, which I did for my PhD, is a natural example of that. But there are more, almost all the things that I did are somehow related to that. So for example, a little bit I worked on Archimedes geometry, and I worked on curves over finite fields, and I also worked a lot on modular forms, also very naturally geometry and number theory mix. And another item that sort of connects the things that I do is the term moduli spaces. So I've worked a lot on moduli spaces. Hilbert modular surfaces are moduli spaces, but I worked a lot on modular space of abelian varieties, principally polarized abelian varieties. And also the PhD students that I have, some of them worked on moduli spaces of curves. I had the privilege of having very good PhD students like Karl Faber, Gabriel Farkas, and Robin de Jong. Yes. So the first little anecdote concerns the table of curves over finite fields, with maximum number of curves over finite fields that I made, which I set up with Van der Vlucht. And this was before the time that the internet was omnipresent. So Geer asked me every time that we make a new version of the table to send him a paper copy. And so I did regularly. And one day I got a letter from Geer saying that he was surprised to see a certain item in the table. I shoot in the table lists the maximum number of points on a curve over a finite field, or an interval in which this maximum number is supposed to lie. And he was surprised at a certain upper bound. And so I could write him back an ironic letter saying that the upper bound that he was referring to is usually called the Geer bound. And so I sent him this, but of course my letter crossed with a letter of his that in the meantime he had found out. So this little anecdote shows the boundless amount of energy that Geer was able to spend on mathematics. Besides all the other things, he was able find the time and energy to go through all these items in the table. I mean, it's amazing for me. So that is one anecdote. And then another anecdote deals with the topic of asking questions after a lecture. So once I was at a conference in Eglofstein, which is not so far from Erlangen, and one morning at 9 o'clock, surprisingly, the lecturer was not yet there. But even more surprisingly, Fabrizio Catanese, who always asks a question at the end of the lecture and who almost always comes a little bit late, he was there. And then Wolf Bart, who was the chairman then, spoke the unforgettable words, "Why don't you ask your question now?" So that was a very nice thing. And maybe a little anecdote is from here, from Bonn, where which was told to me by Hirzebruch. And so one morning, Hirzebruch went to the lecture building in the Weglerstrasse to give his lecture at 9 o'clock. And when he arrives there, he sees that Brieskorn comes out of the building and is leaving. And so he asks, "Herbert, are you not going to give your lecture? Are you leaving?" "Yes, well," said Brieskorn, "yesterday night, while preparing my lecture, I hit upon a little problem. But it turned out to be a big problem, and I worked all night, and only by daybreak I was able to solve the problem. But now, of course, I'm too tired to lecture, so I came here to tell the students that I'm too tired to lecture." And then Brieskorn left. And Hirzebruch reflected a little bit on the way he had prepared his lecture by looking, when he had to stop for a red light, at the manuscript which was lying on the empty seat next to him. But he went in quickly because he was already late. So these are my little anecdotes. Yeah, one moment I remember very clearly, which was in the night before Easter Saturday 2002. I had been working with Karl Faber, counting points on curves of genus 2 over finite fields in order to be able to determine the cohomology of local systems on the moduli space of abelian varieties of dimension 2. And we had come quite close, we had sort of working formula, except up to an additive integer, an additive small constant. And we could not determine it, and Karl was very pessimistic about it. And then at 4 o'clock in the night, which I mentioned, I woke up and I realized that so this problem is related to determining also the eigenvalues of Heckel craters. So I realized that in the beginning, the eigenvalues of the Heckel craters are always very smooth numbers, very highly divisible numbers. So I thought that maybe would give us a clue. But it was too early to wake up without waking up the whole family. So I waited and I could not sleep. And then I finally at 6, I decided it was late enough to wake up. And I went to the computer and started working. And then by 10 o'clock, in the meantime, I had already had my breakfast too. It worked. So I wrote a very enthusiastic email to Karl Faber, who was in Stockholm at the time. And well, then quite soon came his answer, and the answer was a little bit disappointing for me, because he said, well, we have already made so many heuristic assumptions and now you are going to make another one. So it was slightly disappointing. But then later in the afternoon, I got an email from Karl. He had calculated many more things. And yes, it seems quite likely that on the basis of this, we would be able to guess a working formula. And so it worked. So this was my eureka moment in the middle of the night. Yeah. It is very difficult to say, but I could have been a physicist or an astronomer, or maybe a linguist, because I like languages a lot. But I find it very difficult to say, because a parallel universe, then so many things would be different. So. Many things. I like languages a lot, for example. So, I like painting, not actively painting myself, but well, the 20th century was a fantastic era for modern painting, so that's what I like. I also like physical exercise, so hiking and biking, so that is what I do. Yeah, well, such an advice should, of course, depend very much on the personality of the person that in question. And I think for attacking our mathematical problems, you need all these different personalities, like a big army where you need all sorts of people. Yeah, so one of the big advantages of a mathematician is that you can choose your topic that you're working on yourself. And that is, of course, a big privilege which you don't have in other sciences, because you are dependent maybe on investments or a large group of people in which you are working. But in mathematics you have this privilege, but it is also a responsibility and a burden. So, but anyway, my advice would be choose the right topic to work on. Choose a topic that you really like and that you think it is worth working on. Forget the fashions. Fashions come and go, but follow your own taste and choose the right topic. This is a very nice institute because on the one hand there is so much activity, there are so many people to speak to, there are so many lectures where you can listen to, but on the other hand it also offers the possibility of just quietly concentrating on the work that you would like to do. And that is a wonderful combination, and that is very characteristic for this place here. And so it's also a very nice building in a nice surrounding, so for me, ideal place.